All right, guys, welcome back. So we're taking a look at 2.2, the idea of completing the square. So completing the square is a method we can use to create perfect square trinomials, where a perfect square trinomial is in this form right here, a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, giving a plus b or a minus b squared. Which is an actual number, we'd have x squared plus 12x plus 36. That would become x plus 6 squared. So the idea behind completing the square is recognizing that the relationship between the numbers in this kind of problem. For example, if you take a look at the middle term here, the 12x, if I take half of that and I get 6, that's the x plus 6 squared part, and I square the 6, there's the 36 right there. So that's our relationship. So if I don't have the constant at the end, I just have the variable term, I can create what number I need to make it perfect. So the way we do that is we separate out x squared plus bx from whatever the constant is that's in the problem. It's a separate part right there. We find half of b, we square that, and that's what we're adding on to the expression. And then we can write our perfect square term based on that. So we need to make sure it's a balanced expression, though. So we can't just simply add a number into it and that's just it. We have to make sure whatever's adding in is also subtracting on the outside. So this is necessary to keep the results of the expression the same while changing how the expression looks, which is what we do a lot of times in math. A lot of times in math we do change how the expression looks without actually changing its value. So the idea here is we're going to separate out the x terms and that negative 10. And then filling in the blank there, well, we take our 8 off to the side. Half of 8 squared would be 4 squared, which is 16. Now to balance the positive 16 we put into the problem, we need to put in a negative 16. So whatever we're adding in inside the parentheses, we'll subtract on the outside of the parentheses. Inside it, we've now created our perfect square expression because half of 8 squared is 16, where now the expression being squared is now going to be x, and then half of 8 was 4, so plus 4, and then minus 26 on the outside. So assuming everything is nice, there's nothing in front of x squared, the x term in the middle is an even number, it's a very straightforward process, nothing too fancy. When there is an odd number there, all that's going to happen is you're going to create fractions. We still separate out the x's from the constants. And we still want to fill in those blanks to keep it balanced. Positive on the inside, negative on the outside to balance it out. This time, taking half of negative 11 doesn't give us a number, so we just have to square the fraction. We get 121 over 4. So that's what we're balancing on the outside as well. So inside is just simply x minus 11 halves squared. On the outside, the 8 is really 32 over 4, so because we have to get a common denominator we're trying to subtract there, so the 8 becoming 32 over 4, subtracting with the 121 over 4, gives us a negative 89 over 4. So that's what's happening if it's an odd coefficient in front of the x. You're just going to create a fraction there. How we do it doesn't change. Still half of the middle term, square it, that's what they can fill in for the plus on the inside, and then minus on the outside, always trying to balance it out. Now, where it can get a little more interesting is when there's a number in front of the x squared. So to do this properly, we have to factor that number away from the x terms, because we're splitting the x's away from the constants. I do not need to factor it away from the 11, the constant in the problem, because that's not part of the expression that's going to be on the inside. So I only factor the 4 away from the x squared and the 16x part. We still find the missing term by doing half of the middle term and squaring it. Half of 4 is 2. 2 squared is 4. We're balancing the positive 4 with a negative 4, but it also has to multiply by the 4 in front. This number right here has to match right here as well, because technically, we're not just simply balancing a 4 in the problem, it's really 4 times 4 that we're trying to balance. So that's why for something like this, we're going to get 4, and then it's x plus 2 squared. We get 11 minus 16, which becomes x plus 2 squared minus 5. So we have to always balance with the number that multiplied on the outside, because again, the 4 we're adding in is adding inside that has to technically multiply that 4 on the outside. So we're still doing a minus 4, but now it's times 4. And if we factor out a negative number, you have to be even more careful. So we factor out the negative 9 from the x squared and the negative 27x, creating an odd, not ideal, but we'll persevere. Half of 3 doesn't go nicely, so we just square it and get 9/4. And again, it's positive 9/4, so we're balancing with the negative 9/4, but that multiplies by the negative 9 that's in front of the entire expression. Well, that means that we have negative 9, and this is then x plus 3/2 squared. Well, the negative 9/4 times a negative 9 is going to be a positive 81/4, and the negative 4 has got to be 16/4, so we have that common denominator. So then we can add them together, and we have the negative 9x plus 3/2 squared, and then we're going to get a positive 65/4 for the expression on the outside. All right, so that's what's got to happen. You got to be careful when there's a number outside the x squared that has to be factored away. Make sure that that's balancing with the number you're putting inside as well. The whole goal is whatever we're creating right here, if I were to, not that I would want to, but even if I were to FOIL the x plus 3/2 squared expression, distribute that with negative 9, combine that with 65/4, I better get back to negative 9x squared minus 27x minus 4. And the only way I can do that is if I follow this exact process. The number I'm adding in, half the middle term squared, the 9/4, has to balance as a negative 9/4 on the outside, multiplying with the negative 9 that was factored away from the expression anyway. Okay, so that's our completing the square. We're going to use this. We're not going to probably use this again until we get back to Unit 8 with our conic sections, but it is going to be an important tool, so you want to make sure you hold on to this memory and then obviously refer back to this video when we're doing Unit 8 stuff. So next video is going to be your long division and synthetic division for dividing our polynomial expressions. So I'll see you next time.